This is part two because the other video ran to the end of the memory. Sorry. So where was I? Talking about perpetual motion. Perpetual motion basically means that how does everything stay in motion and being more accurate the way I'm going with Chronocosmonomy, that will include the sun. Now, get ready for this because this is a very important point that you would have to learn. It's a law. It's being posited as a law. And so for the first time hearing this, rotation has been enormously underrated and ignored. Rotation is a new law, and it states that all celestial bodies, spheres, rotate. It's an internalizing, quote unquote, internalizing motion. It comes from within. There's a power inside of there, and I'm not going to get into all the details, but that force inside of the sphere will cause the body to rotate. And it's basically saying that the rotation also causes a resulting motion. Like you can't have one without the other, in other words. If there's rotation, there's going to be the other motion. And that is the motion of forward motion. So I just said something was so huge, like in the other video, not part one, but the video that I did entitled Neptune Centric. So now you're starting to put together all the puzzle pieces to understand chronocosmonomy and the new system model. Now, what did I just say? What earth-shattering thing did I just say? Rotation is together with another motion. No one has ever known this before. Nobody. Because there was no law until I had to write the law. I had to discover it. It blew me away. It still blows me away. It's always going to, because I'm fascinated by the universe. How can I express it? I'd have to give up my studies to be a poet and try to put these things into words. Some poems. But you have to take my word for it. Just briefly, concisely, I'll tell you that it's so completely fascinating to discover this law that has not been known until I came across it. Rotation of the body is intertwined, is linked, is causing another motion. So rotation is such a root of the motions that we have thought we've been seeing, but I'm going to make you be able to see it even better after you see that the rotation is doing something like twice or three times as much as anyone ever thought it was doing. It's creating a forward motion, which is a curve. It's a line, but yet it's curved. but not for the reasons that were stated previously before my work. There was other work before me, and before that, and many, many, many layers going all the way back. I'm not going to name any names. Let's just stay focused on my name, what I'm saying, Toschiati in the Chronocosmonomy. The rotation causes the forward motion on a line, curve, a path. I call it, quote unquote, the orbital path. It's not an orbit, it's an orbital path. Because really, when it boils down to it, nothing is orbiting anything else. Like, strictly speaking, it's not. It seems to, and I can also say there is certainly no elliptical orbits. An ellipse is an incomplete theory as well. You see, what happens with the celestial sphere? Just isolate it and take it as its own, which you really can't do unless they're wandering bodies that have no system and they're just alone. We are not sure of that. It's not that common. If it does exist, it's rare. But just for the sake of understanding what's happening with the rotation of a body, one body problem. When it's rotating, it has a forward motion. That's an orbital path. It's going to continue on that path unless it encounters a force that will affect it, which would be any other celestial body. If it doesn't, it's going to continue along in that line. But it's going to be a curved line because of the rotation. So in order to see that, you have to put everything on its side. You have to turn everything 90 degrees perpendicular at least, and then flip it around from the way that we're accustomed to looking at it, the conventional way, or the old way of looking at it. You have to put it on its side, see the rotation that way. The rotation's not this way, it's this way, and then you turn it around and you say, oh, this way also. Like, am I getting it right? So on the side, when you're looking at the rotation, you start to understand, just like some planets are that way. Usually. They're perpendicular rotation to the ecliptic plane. Yeah, you knew that, right? Well, I'm just telling you, reminding you. But most of them rotate lined up, you could say, to use it in layman's colloquial terms. The rotation is lined up with the ecliptic. But we have to turn everything on its side in order to understand this better. Now, what I was saying about the perpetual motion, when you have multiple bodies, 2-body, 3-body problem, n-body problem, right? And going into physics, celestial mechanics, when you see multiple bodies in space, they are going to interact. So, and their interaction is to kind of jockey around each other, and the one with the most mass is going to take a certain position where the other ones are on the orbital path next to it. But then it's going to jump to the other side. But the one that has the most mass, which would be the star, but if there's multiple stars, binary and more, what's happening? It's getting complicated. But when there's one star, which is what we've got going on, it's more simplified. There's one star, it's on its orbital path, but it's also going around something. And for me to explain this to you, how they all come together, I would have to get into cosmology. So tonight's discussion is not going to be about the cosmology. Not tonight, but this lesson is not about that. That's way too advanced. So we're going to add that on later after we get through this. We all understand it. We discuss it together. So you've just imagined the orbital paths going alongside each other. They're not going around, because here's the key thing that you have to start all of your thinking, all of your study now into the Chronocosmonomy model. You have to realize that the sun is rotating, so it also has a forward motion. It's just like any other celestial body. If it rotates, it moves forward on a curved orbital path. So you really need to absorb that, think about it, understand. There's other words I could be using, but that's the quickest way I can explain it for this lesson. We can analyze it. There's a lot of paperwork that you're going to be reading, the book and all the diagrams especially. And take a deep breath. The most important thing that will happen is that I complete the part of the project, which is the animation of everything that I'm talking about. It's like a visual, computer graphic animation. I'd like to do a lot of it as, manual artists, like the old Disney style of cartoon animation. But, the computer can be used to make that process faster. I just want to make sure that the original artwork, the original visuals are done by hand. That's really what I'm going for, because it's sort of connected in with the Chronocosmonomy style. I mean, how else do you think the Chronocosmonomy was discovered? It's not by reliance and dependency on the computer to do your thinking. I didn't allow the computer to do any thinking. I did all the thinking in here. Billions and billions and billions of thoughts and calculations. So the next thing we need to understand is that mass cannot keep its momentum of its motion unless it's the furthest out from the center. And this was not understood by a lot of the physics that were being taught, and there's a centripetal force. But beyond that, not dwelling on the fact that it's supposed to be fictitious and it's not really a force, but thinking about when you do something like a gyroscope, you would have to see the system as a gyroscope. A gyroscope doesn't work with the weight in the center. The center is just the anchor. That's just what it's attached to. The mass has to be on the outside and swinging it around like a slingshot. If you put the rock in your hand and you swing it around and think you're gonna like hurl the slingshot, it ain't gonna work. So you put the rock at the end of it, and you have the slingshot itself, and that's, I hate to talk about weapons, but hey, it's physics. So when you're swinging that around, the faster you swing it with that mass going out, it's not going to stay to the center. It's going to go to the outside. So then, oh yeah, I know what you're thinking. Like, wait, what causes that how would that be attached? to Neptune. If I was saying before that the sun doesn't move and how could there be chains coming out of it attached to other planets, but how I'm switching Neptune for it, no, I'm not. Neptune also is rotating and moving forward, but it is the most steady and consistent motion of our solar system, Neptune. And everything else is going around it in these wave shapes. Okay, just imagine everything's going in the same direction. And sometimes the inner planets around the sun, that whole group is over on this side, and then at other times it's on the other side of Neptune. Other times. And there's a long, long cycle, and it repeats this cycle. I'm not going to go into all the years and the measurements of those cycles, but just imagine that it is periodic. But Neptune is the most steady of all of the celestial bodies. It's Neptune. And there is several reasons for that, but we would have to get into the explanation of all the cosmology, and that's not the subject of this lesson. This lesson has been about dissecting, first being skeptical and questioning the heliocentric, and then having to expand on it and seeing a much bigger view of what's going on. And I just have to say, this has been like the heaviest, biggest lesson that I've put out in a while, maybe ever. So it is going to be something that we are going to do a lot of classes, always referencing and using these videos. I got part 1 and part 2 now of this, because the core ideas of the whole new system are in this video now. Perpetual motion, the law of rotational. There's also motional laws, which I call emotional, from motion. 1 motional, 2 motional, 3 motional, and that is a set of laws as well. So how I will wrap this up is by telling you that I'm not discarding the heliocentric, just as a heliocentric revolution of ideas, not revolution orbit. It's the revolution of thinking. But that revolution of the heliocentric did not completely discard the revolution of the geocentric. It didn't. It just built upon it and went further, and it made things more complete to the human understanding, or to the science of the universe. But what I'm doing right now is I'm including the geocentric, and then I'm building on it with the heliocentric. I'm like reassembling the heliocentric part of the equation, and then I'm building another layer on it, which is completely necessary for us to advance science. Now, there's another very minute, very fine-tuned complication that is involved with it, and that it would be the Earth to the moon. And that, I'm not even going to start to talk about that because there's so many details to it. But I will say that as we have these centers that are built upon each other, the Earth is still can be considered to go around the sun. and then the sun can be considered to go around Neptune. But what you have is the Earth and the inner planets forming a group. It's a component that stays together, and I call it the nucleus of the system. And in that nucleus component, not focusing on the other ones, including Neptune, just focusing on the sun with Mercury, Venus, Earth, and Mars, and the moon, and also the two around Mars, up until the asteroid belt. That's the nucleus. So when you look at that, you can look at it as one unit, not separate. You can look at it separate, but it becomes very complicated. But when you take it as one unit, it's more easy to see that that one unit is going around Neptune. Instead of trying to see, how do all those planets go around it? Well, it's that one unit, and that's why the asteroid belt forms around it. It's this one unit going. And then you've got Jupiter, Saturn, Uranus, up to Neptune. You only got 3 more after that. So that is the general design of everything. And I think I've already said quite enough for this to be a full day of study, a lecture, and a presentation. We're going to have the visuals. It's always difficult for me and any other teacher